Hey guys, Professor Dustin here. This video is going to be about Newton's third law pairs. So these are pairs of forces which we know exist because of Newton's third law, but we also know how big one force is relative to the other due to Newton's third law. So recall Newton's third law is for every action there's an equal and opposite reaction. So if there's a force pushing from one object to a second object, there is definitely a force acting in the opposite direction with the same magnitude from the second object back to the first object. These are often called action-reaction pairs. That name is a little misleading because it implies that first there's the action and then later there's a reaction, and really these two forces happen simultaneously. It's not like after one happens, the next one happens, they happen exactly at the same time, but the language action-reaction is still pretty descriptive of what's going on. The best example of an action-reaction pair is if I push on the whiteboard pushes back. No matter how hard I push, with whatever force I like, the whiteboard will still push back in the opposite direction with the exact same force. So this action-reaction pair told us not only that another force existed. When I pushed, I knew there was another force that existed because of Newton's third law. I knew there was a force that pushed back from the whiteboard, but it also told me how big that force is. So if I push, I know how big the whiteboard force is if I know how hard I push. So that allows us, when we use free body diagrams to solve problems, it allows us to know there's another force that should be in our diagram. And it also allows us to know how big that other force is. And that can be a critical step in figuring out how objects move. So this has been a quick video about Newton's third law pairs, also called action-reaction pairs. It's critical to understand this kind of stuff if you're going to solve problems with more than one object in them, because often there'll be internal forces between objects in the system, and you need to know something about those internal forces in order to understand the motion of the system as a whole. Okay, great. Thank you guys for watching, and I will see you next time.